Hi, everybody. This lecture is going to be over 8.1, 8.2, and 8.3. So I don't think I'll be able to cover every single question, but I'll cover the highlights of each of these points. So started off with 8.1, the fundamental counting principle. A 20-sided dice is rolled. How many possible outcomes? Well, you're going to roll two 20-sided dice. Each dice has 20 sides to it. It's very unusual to see one of these dice, I guess, unless you play Dungeons and Dragons. But there are 20 outcomes on the first dice, 1, 2, 3, 4, 5, all the way to 20. And same way with the second dice. It's got 20 sides to it, 1 through 20. So if you multiply those two together, there are 400 outcomes, right? Because you could get a 1 and a 1. A 1 and a 2, a 1 and a 3, all the way to 1 and 20, then a 2 and a 1, 2 and a 2, 2 and 3. There are 400 outcomes this way. So the way you do that is multiply the number of outcomes on the first dice, multiply the number of outcomes on the second dice, and then multiply them together. All right, question 2. A person can rent a studio, a 1-bathroom or a 2-bathroom apartment. So you have 3 choices here. A studio, a 1-bedroom, a 1-bedroom, or a 2-bedroom. There are 3 choices here. You can also choose not to rent a parking spot, rent an uncovered, rent a covered, or rent a garage. So you have 3 choices on the type of apartments. You have 4 choices on parking. And then it says how many outcomes are there, where if there are 3 choices on an apartment and 4 choices on parking, there are 12 possibilities. 3 times 4. All right, so now let's get into some of the actual problems in this section. How many license plates can be made if the first 3 characters are letters and the last 3 characters are digits? So we're assuming this license plate has 6 spots that need to be filled in. So the first 3 characters are letters. There are 26 letters in the alphabet. Assume letters and numbers can repeat. So the first spot, you can have A, B, C, D, E, F, G, all the way to Z. There are 26 characters, 26 letters. The second spot, you can have 26 also, because you can have an A and an A. You can repeat a letter. And the third, you can have 26 possible letters there. Now, the last 3 are digits, 0 through 9. If you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 10 digits. 10 digits, and you can repeat. So they want to know how many license plates we can make. Just multiply all these together. 26 times 26 times 26 times 10 times 10 times 10. And it's a lot. 1757600. So 17,576,000 license plates. So for a small state, not like Texas, Texas uses 7 spots for the license plate. For a small place like Maine, they can make 17 million license plates and never repeat. I don't even know if there's 1 million people in Maine. I'm sure there are at least 1 million. We have, close to 2 million just here in San Antonio. All right, I'm moving on. Here we go. If a final exam has 25 multiple choice questions, each has 5 choices, how many ways can a person answer the question? Okay, so we have 25 questions. 1, 2, 3, 4, 5, and this is number 25. And each question, you have 5 choices, A, B, C, D, or E. 5 choices, and I'm going to multiply all those together, right? 5, 5, 5 times 25. I can just put this into my calculator. 5 multiplied together 25 times. 5 raised to the 25th power. 5 raised to the 25th power. Oh, by the way, I should have been doing this on the calculator here, if you can see that. Let's see if I can do a zoom in, or maybe I should make it bigger. There we go. So I'm just doing 5 raised to the 25th power. And it's a huge number. It's in scientific notation. It's huge. What it is, the answer for this problem is 2.98 times 10 to the 17. In other words, you times 10 to the 17, it means you move this decimal place 17 times to make it larger. Each time you move it, it's a factor of 10. So you move the decimal place 17 times, 298. I'm getting rid of the decimal. So I moved it 2 times to get 298. Then I have to put 15 zeros here. There's 15 zeros. So it's this huge number. Leaving it in scientific notation is fine. All right, so that was 8.1. 8.2, a couple of things we need to learn. 8.2 is permutations. One of the things we need to learn is this symbol here, 5. That's called factorial. 5 factorial. 5 factorial, when you have 5 factorial, whatever number shown, you always do 1 less after that. 1 less, 1 less, 1 less. And when you're at 1, then you stop and multiply them all together. So 5 factorial, 20 times 3 is 60, equals 120. When you multiply all this together, you get 120. Okay, so let's do this on our calculator. 5 factorial. And we should get 120, just like they got here. So first you type in 5. Then you go to probability. And down to number 3. Do you see the factorial symbol? So now you have 5 factorial. If you hit enter, it gives you the answer. 5 times 4 times 3 times 2 times 1 equals 120. All right. Let's see what else we have. Let's take a look at question 2 and 3. Question 2 and 3. So they're a little different. So how many 3-letter codes can be formed from the letters A, B, C, D, E, F, G, H? So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to do a code with 3 letters in it, and there are 8 letters that we're allowed to use. And it says you can repeat, so I can have A if I want. So there are 8 letters I can use for the first letter in the code. There are 8 letters I can use for the second letter in the code, and there are 8 letters in the third. So the answer is, how many different codes can I create? 8 times 8 times 8, 512 different codes for this code, for this 3-letter code thing that I need. Now, in the next one, we're going to use 3-letter codes, the same number of letters, 8, but you're not allowed to repeat any letter. So if I use A in the first one, I cannot have A in the second one or the third one. So I have 8 choices for the first code. Now, since I used one of the letters, I cannot repeat that letter, so I only have second letters to choose from for the second part of the code. And since I used 2 already, I only have 6 letters for the next part of the code. And this is how a permutation is done. You're choosing 3 from 8. It's 8 times 7 times 6, and you get 336. Do you see? If I am not allowed to repeat, I only have 336 different codes. But if I can repeat, I get 512 codes. When you do it like this, this is called a permutation. And one way of doing a permutation on your calculator, by the way, I have 8 codes, and I'm going to choose 3. So let's plug this into our calculator. If I have 8, and I cannot repeat, permutation, you can't repeat. So I have 8 codes. I'm going to type in 8. Then I'm going to hit probability. This is a permutation number 1. And I'm only going to choose 3 of the letters. And if I hit enter, I get 336. Do you see? It's the same thing. 8P3 is the same thing as this. Choosing 3 with 8 without repeating. This is called a permutation. Okay. Here's another permutation. How many ways can I stack 5 boxes? If I have 5 boxes, I can distinguish them from one another by labeling them 1, 2, 3, 4, 5. I put 1 box here, then I only have 4 boxes to choose from to put here. Then I have 3 boxes, then I have 2 boxes, then I have 1 box. So first, I pick 5 out of 5 boxes. I can pick 1 out of any 5. Then I have 4 boxes to choose from, 3 boxes, 2 boxes, and 1 box. When you multiply that together, you get 120. Another way of writing this is I have 5 boxes, and I have to choose all 5 of them one at a time. So I'm going to do a permutation of 5P5. And it should add up to 120 because we already showed it's 120. 5, probability, number 1, 5. I'm choosing 5 from 5 boxes, and it gives me 120 possibilities. All right, and then there's some more they have you do. You can just plug these right into your calculator. Let's do one of them. Let's do 5A. Just do 9. Probability number 1, enter 3. and I get 504 on my calculator. So did you get 504? And there'll be a couple of questions on the test that match that or look similar to that. All right, let's keep going. In how many ways can 4 people have a different birthday, assuming there are 365 days in a year? So we're going to have 4 people have a birthday. 1, 2, 3, 4. They all have a different birthday. So this person, let's say January 1st, there's 365 days he can pick. The next person can't have a birthday on the same day. It has to be different. So 364, then 363, and 362. In other words, we have 365, and we're choosing 4 different days. 365 on my calculator. Probability number 1, and we're choosing 4 different days, and we get in the scientific notation 1.7458 times 10 to the 10th power. It's a huge amount of different different outcomes. Let's take a look at this next one. There's a couple here. I want to look at this one, all 3 of these really quick. So there's a formula we need to know. It's on our formula sheet in our workbook. The formula is this. Anytime we find the number of outcomes when we have words with letters, so this is the number of outcomes with words and letters, words. First, it's n factorial divided by, I don't know what, I think the book might use different letters, R, P, Q, S. I could have did a couple of different letters. But N is the total letters, and these are repeating letters. If you have more than 1 repeating letters, you have to put more and more. So if you look at math, there are 4 letters in the word math. The number of how many repeating M's do we have? 0. How many, actually I only have 1 M, 1 factorial, 1 A, 1 factorial, 1 T, 1 factorial, 1 H, 1 factorial. By the way, if you put 1 factorial on your calculator, you just get 1. 1 factorial equals 1. So in this case, the top is 4 factorial. We have 4 letters. How many different words can we create? You have 4 letters to choose from. Then if you used 1, you only have 3, 2, and then 1. So there are 24 when you multiply all these together. Here is the same thing. It's 4 factorial divided by 1 factorial, which is 4 factorial divided by 1. And it's 4 times 3 times 2 times 1, which equals 24. Now, the next one, there are 4 letters. So the top is the total letters, 4 factorial, and the bottom is how many repeating letters. Well, the L repeats 3 times. and then the u repeats one time. So you don't have to put the 1 factorials, the u, because 1 factorial is 1. So when you put this in your calculator, by the way, 4 factorial is 4 times 3 times 2 times 1, and 3 factorial is 3 times 2 times 1. Do you see how these cancel? And the answer is just 4. So the answer to this problem is 4, but you can write it as 4 factorial divided by 3 factorial. Let's take a look at that. 4, probability number 3, 4 factorial divided by 3 factorial. And do you see how you get 4? So 4 factorial divided by 3 factorial just equals 4. How did my name all of a sudden pop up there? I don't know how that got there. I don't know if I did. I don't know what happened, but all of a sudden, it's gone now. Good, good, good. Okay, how many 7-letter words can be formed from this word? 1, 2, 3, 4, 5, 6, 7. So the top is 7 factorial because there's 7 letters. I have S 3 times, 3 factorial. I have C 2 times 2 factorial. And I think that's it. U and E only happens once. So I'm going to put this in my calculator. And first I'm going to hit the fraction button. And I have 7 factorial divided by 3 factorial times, I think it was 2 factorial. Oh, I hit the wrong one. How do I go back? Hit delete. 2 probability factorial. There we go. And then arrow over, hit enter, and I get 420. So the answer is 420. So when you have letters and you're trying to find out how many different words you make, you have to use that formula. The top is the number of letters. The bottom is how many repeating letters. If nothing repeats, you just put a 1 on the bottom. Not going to do that one. Okay, 8.3, combination. So combination is a little different from permutations. So let me write something down here. Something that we need to remember for permutation. We need to remember that order matters. Now, the way I also do permutation is each blank spot is labeled, has a different label, is different. Each blank spot is different. Let's put it that way. Okay, each blank spot is different. Combination order does not matter. And each blank spot is the same, is labeled the same. So if we look at this, a 3 committee member is to be selected. So I'm going to collect 3 committee members. And each one is a committee member. I'm calling them CA. Do you see how each blank spot is labeled the same? They're each a committee member. And they want to know, is this does this problem involve a permutation or combination? Well, each blank spot is the same, so it's a combination. So let's say we have 7 people and we're picking 3, but they're committee members. So this is a combination, 7 combination 3, 7 combination 3. We're picking 3 from 7, and each job that they're going to do, committee member, is the same. So on my calculator, I'm going to do 7C3. 7 probability combination 3, and I get 35. Okay. By the way, in the combination, Joe, Mike, and Alice is the same thing as Mike, Joe, and Alice. Do you see, in a combination, they're all the same because they all get the same job. If you pick Joe, Mike, and Alice for committee members, it's the same thing as picking Mike, Joe, and Alice. Do you see, it's the same. It counts as one. But in a permutation, Joe, Mike, and Alice is different from Alice, Mike, and Joe. They're different. For a permutation, those are different. And I'll show you why here on the next problem, problem 2. So in problem 2, we have to pick 3. Let's say we're picking 3 from 7. We're picking 3 from 7, and the first person we pick is going to be the president. The second person is going to be the first vice president. The third person is going to be the second vice president. Do you see? Each job is labeled differently. Each job is different. If each blank is different, each blank spot is different, it's a permutation. So this is going to be 7P3. And do you see each blank spot is going to count different? Mike, Joe, and Alice is going to be different from Joe, Mike, and Alice because one of them is going to be the president. And it matters who's the president. Permutation, the order matters because the first person is going to be president. So 7P3 on my calculator is 210. And do you see in the first combination, we only had 35 possibilities because the 3 names can be done several times, but they only count as once. Here, the 3 names, Joe, Mike, Alice, Mike, Joe, Alice, each count differently. So do you see that each is different because each spot is different? Up at the top, each spot is the same. Permutations will always be a higher number than combinations if you're using the same thing. In this case, 7, choose 3. Permutations will always be a higher number because they count separately. Combinations, the same 3 numbers, doesn't matter what combination, will always equal the same amount because their job is the same. Okay, so let's move on. We could try one of these on a calculator. Let's try 7C4. 7 probability combination 4. The answer is 35. So in how many ways can this be done? 3 committee members from 15. So we know committee members, we have 15 and we're choosing 3. We just put it in our calculator. 15 probability combination 3, and I get 455. Once again, here's 15 and we're choosing 3. Each spot is different. This is 15 permutation 3 because each spot is different. Each spot is labeled different. You have a president, you have a vice president, and so on. And that was 8-1, 8-2, and 8-3. I hope that video helps.